Right guys, welcome back to Matrix Uploaded. Let's look at horizontal and vertical lines. Okay, grade 11s, you must be listening. Remember, we've got the line y equals 3 as a horizontal line, and the vertical line goes through. Notice the x's are the same here, and for this one, CD, the y's are the same. Okay, now if you look at a vertical line AB, let's work out the gradient of AB. Okay, 4 minus negative 3 over negative 4 minus negative 4. Now what's interesting here is you're going to get 7 over 0, which is undefined. You can't divide 7 by 0. So what we know is that the gradient, this is important, the gradient of a vertical line is undefined. Okay, now, so what we can say is, and the angle of inclination is 90 degrees as well. Gradient of AB is undefined there. Okay, for this vertical line. What about a horizontal line? Now this is very important for calculus matrix. If you've got a horizontal line and we work out the gradient of CD, so we say 3 minus 3 over 4 minus negative 6, we'll end up getting 0 over 10, but that's cool. 0 divided by 10 is 0. So what do we know? Which is 0. The gradient of a horizontal line is 0. Absolutely. Remember that. That's important. Okay. Gradient of a vertical line, undefined. The gradient of a horizontal line is 0. The equation of a horizontal line is y equals number. The equation of a vertical is x equals a number. Okay. And the angle of inclination is 0. Okay. Good. Now let's have a look at a few for grade 10s especially. You're going to do a lot more of these. We can have different quadrilaterals, a trapezium there, where the two sides are parallel, a parallelogram, where the opposite sides are equal, they're parallel, the opposite angles are equal. The grade 10s are going to do this in a lot of detail. The diagonals bisect each other, they cut each other in half. Okay, you might get a rectangle where it's a parallelogram with the diagonals being equal. Notice how they cut each other, the opposite sides being equal. We're going to use this one as well in the example that follows. And the interior angles are all 90 degrees. Doesn't that remind you of the product of the gradients is -1 in this thing? Okay, then you've got a rhombus. This is like a little square that's tilted, and all those angles are equal, etc. And you've got all the sides being equal as well in the rhombus. Okay, and the diagonals bisect each other at right angles there. Opposite sides, all the sides opposite each other equal. Likewise with the angles there. A square, very good point here. All the sides are equal. The inside angles are 90. You've got 45 and 45. All these little sides are equal, and it's really a sort of a rectangle where all the sides are equal. And then a kite, a nice one. These adjacent sides next to each other equal, and the diagonals are at right angles. And of course, they bisect the angle. This diagonal bisects the angles, cuts them, makes them equal, and those two line segments are equal. Okay, let's look at an example quickly. We've got some points in a number plane, and these, the A, B, and C, and D, are the vertices of a quadrilateral in a Cartesian plane. And we want to prove that A, B, C, D is a rectangle. Now, what you need to do is you need to draw a picture. Okay, now let's plot these points and see what we have. Okay, well, there we go. A is 0, 4, it's not to scale. B is 3, 1. You could probably draw it to scale if you wanted to. C is -3, -5. And D is -6, -2. Where did I get those points from? From here, from that top bit. And we want to prove that this is a rectangle. Well, firstly, what we need to do is to prove it's a parallelogram. Okay, and then we can go ahead and so if the inside angles are 90 degrees, you see, if these are 90, then it must be a rectangle. Okay, so how do we proceed? Well, there's many ways you could do this. And grade 11s, what I would suggest that we do is we take those points. Let's look at the gradient of AB. Now, I'll show you something. If you go, the gradient of AB is 1 minus 4 over 3 minus 0, gives you -1. And if you look at the gradient of AD, is minus 2 minus 4 AD, so it's those two, minus 2 minus 4 over minus 6 minus 0, which is 1. Okay, there. Okay, the gradients of AD. The gradients of CD, you can work it out as minus 1, and the gradient of BC is going to be 1. Now, if we look at this, what do we do with that? The gradients of AB is equal to the gradients of CD, and the gradients of AD is the gradients of BC. Okay, now, AB is parallel to CD, and AD is parallel to BC. So what does that mean? Let's talk through this. We've worked out, if you look here, that the gradient of this line of AD is 1, the gradient of BC is 1. So these lines are parallel because of equal gradients. We worked out these are parallel because the gradient of AB is minus 1 and the gradient of DC is minus 1. So again, the opposite sides are parallel, making it a parallelogram. Okay, now we've got to do something further to prove it's a rectangle. Stay with us on Matrics Uploaded. We'll be back soon.